Yeah, comes on everyone. Sure. So last class we have done with the case one when the person is going with the river and opposite to the river flow. So case two, others do keep your cams on. I hope everyone has resolved the paper. Did you guys resolve? Do resolve the paper on Thursday. We can discuss that out. So it is important you resolve the paper. See, if you have done well in the paper, there's no problem. If you messed up the paper, you should definitely see the paper and see each and every question why you messed up. The reason why you messed up is because you don't know something. So try to figure out what it is. That is important. Case two, minimum distance. So let's say a person wants to cross the river in a minimum distance. That means he swims perpendicular to the flow. So let's say the river is flowing with u. This is the speed of the river. The width of the river is d. And we have a person here. So velocity of the man in still water is v. And let's say in this case, v is greater than u. Means man can swim faster than the river. So this person wants to go from A to the exactly opposite point B. Now, the thing is, if he tries to swim straight, what will happen? The river will push him to the right. He won't to go straight. He will actually go like this, isn't it? So in order for you to go straight, let's assume like this. Let the man go at an angle theta with speed v. See, this is how it is. You don't know how is he going to start with an assumption. Let him go at an angle theta with speed v, and then from there you start. Let man swim at angle theta. So this is how the velocities would look like. So his vertical velocity is v cos theta. The horizontal velocity is v sine theta. On top of it, the river is pushing him to the right side. River is pushing with u. This is the speed of the river. Now he wants to go along the line AB. Since he wants to go along AB, the horizontal component is 0. V sine theta should be equal to u. So sine theta is equal to u by b. So if he swims with this angle, he will reach the opposite point. And how much time is going to take in this process? Now the time taken to go from A to B is AB and velocity along AB. If you're going from A to B, you're interested in velocity along AB, which is d by AB is nothing but v cos theta, and sine theta is u by v. So this would be d by root over v square minus u square. This is the time taken to go from A to B. You can just replace cos theta with b, nothing but d by root over 1 minus sine square theta. There, these are the two important formulas. So if you want to cross the river with minimum distance, swim with this angle. In that process, you will go with this much time. Now, this is not the minimum time. If you try to cross with a minimum distance, you won't get a minimum time. So how does this whole thing look like exactly? So see, this is how the whole picture is looking like eventually. This is what is happening. The man is looking somewhere else. If you look at the man, he's looking like this, meaning he's swimming as if he wants to go here. But if you look at him, he's looking somewhere else, but he's going straight. Are you getting how is the motion? It's like you're looking to the left, but you're walking straight. That is how the whole thing will look like. So the man, right, he tries to swim. This person is trying to swim this way. But he goes this way straight. You're getting, you want to go somewhere, but you're going somewhere else. Is the diagram clear, everyone? You're looking to the left, but you're going straight. Because the river is pushing you. If the river was not there, this person would have gone like this, isn't it? Because the river is rare, the drift got he got drifted this way. So kind of it looks like this. If you think about it, it is like this. Every time he tries to go this way, the river will push him back. He goes this way, river will push him back. He goes this way, river will push him back. Now this is happening at a very minute level, so you won't even notice it. It's like a small bump. It looks almost like a line. Every time he tries to go little, the river will push him back. Please have a look at this. This is the case for minimum distance. He will cross the river by traveling least distance. So he has to put some effort to oppose the river. Let's see a question based on this. Any doubts on case 2, please ask me. Great. Let's see a question. We got a river here. The river is flowing with you. So in this river, someone made a track like this, a square track. So we have a person here who can swim in still water with V. So when he swims, he swims along the square. So find the time taken to complete one round trip. To swim along A, B, C, D, A. He starts from A, he swims straight and then swims here, then he swims here, and then he swims here. So this guy is going in a square. River is flowing to the right. Is the question clear? Find the time taken for him to complete the round trip. Try. You got 2 minutes. Any answers? 2 root VL V square. Yeah, answer would come in terms of LV and D. V square minus V square. Yeah, that looks right, Vihan. Others, try. I'll give you a minute more. See, now when you're going in the square, now understand, when you go from A to B, this is literally case 2. So the man is going with V. He can't swim straight, okay? He has to swim at an angle. The river is pushing with U. So V cos theta, V sin theta. The river is pushing with U. V sin theta is U. Sin theta is U by V. So time taken to go from A to B is length by V cos theta. This is literally case 2. I'm just showing the whole thing again. V square minus U square. Now when you go from B to C, he is going with the river. So this percent ka speed will be V plus U. So time taken to go from B to C will be L by V plus U. This is case 1. Again, when he comes from C to D, this time the person has to swim this way, V and angle theta. Again, the same story. So C to D will also be L by root over V square minus U square. And while coming back from D to A, he's swimming opposite to the river. So he is swimming with V minus U. So time taken from D to A is L by V minus U. So the total time taken for A, B, C, D, A, the total trip would be, just add them up. You'll get 2 times L by root over V square minus U square plus L by V plus U. You can simplify this further, but you got the point. So, and if you look at the whole trajectory, how this guy is actually swimming from A to B, he's actually looking like this. He's looking like this, but he's going straight. Here he is looking straight and going also straight. Here he is looking like this. He's looking to the left, but he's going straight. Here also is actually going the same way he's looking. So on A, B, and C, D, he's looking somewhere else, but he's going somewhere else. Clear? So case 1 and case 2 ka combination is this. Next one. Any doubts on this? Clear, na? Abhinav, Arya, Arnav, Surya, got this? Next thing. Surya, I still didn't get your cam repaired, right? This is too long. You should do something about it. Don't make me remove you from the classroom. I don't want to do that. It's been almost more than a month I told this. Now I start feeling like you are ignoring me, actually. Do something about this. Or else I have to assume you don't give a damn about what I ask. Case 3. Minimum time. So let's say I want to just cross the river in a minimum time. Now, what do you mean by this? Now, see, the main thing is I wanted to cross the river. I never said you should reach the opposite side. You kidding me? So, if velocity of man and still water is less than u, he can never reach the opposite point, but he can cross the river. So he can never reach the exact opposite point. That is, he can't go along line AB. Actually, this is not required. Minimum time to cross the... Wait. No, this is case 4 I was telling. Shit. Minimum time to cross the river. Yeah. Let's say is going with u here. This is D. Again, same story. You want to cross the river in minimum time. I don't know how is he going. So you always start with an assumption. Let the man go with V at an angle theta. Now we can clearly see here the components. This is V cos theta. So V cos theta is responsible for crossing the river and V sin theta is opposing the river. The time taken to cross is the length AB by velocity along AB. That would be D by V cos theta. Now this is the time taken. Now for minimum time, cos theta should be equal to 1. That is, theta should be 90 degrees. So we get the minimum time is d by v, meaning he should just swim straight. Obvious, actually. Think about it. Why should you swim at an angle and waste some of your energy to oppose the river, isn't it? You just swim straight and use all your effort to cross the river. Think about it. Will the river ever help you to cross the river? The river ka velocity will never help you to go in this direction, isn't it? Up and down. The river will take you only left and right. So then why do you want to waste your energy fighting the river? Let it be. You just cross the river with your full speed. But the problem is, this is what will happen. So if you just decide to go straight with V and the river is pushing you with U, so if this is point A and this is point B, you will go somewhat like this. You will reach C. This distance here, BC, is called drift. Means you won't reach the opposite point, but to reach somewhere else. So this is how it looks. See, the man is always looking straight. Huh? The man is always looking like this, but he is going like this. You're getting the difference? Sorry, theta 0, mistake. Cos 0, no? Yeah. Theta 0. Is this making sense? You're looking straight, but you're going like this. So we have something called a drift. Drift is nothing but the horizontal velocity into time. Which is given by horizontal velocity, the speed of the river, and time is d by v. So this is the drift BC. There, see, if you want minimum time, you won't reach the opposite point. If you want to reach the opposite point, you can't get minimum time. You have to sacrifice one of them. If you want minimum distance, forget about time. If you want minimum time, forget about distance. This is your case 3. Is this making sense, everyone? So instead of swimming at an angle, use your full effort just to cross the river. That would be the best way. But in this process, you won't reach the opposite point, you'll reach somewhere else. So that is the drawback. Have a look at this.
So,
Anyone?
so which means in case 3 or in any case, the man thinks he's swimming straight.
But he will reach somewhere else.
Okay, sir. Thank you.
You're looking straight, but you're walking to the right. Meaning, if you look at my screen, right, the hand is pointing front, but it is going like this.
to say about it. Thank you.
All clear with this? Now there's a case for now. See, understand one thing. All these cases are just general cases only. Getting it? If you see in all these things, there's one thing common. What we do every time, man is going at an angle theta, components. We are just playing with that on a relative motion. We are just taking different cases. So questions need not be always from the four cases. They can ask you anything randomly. We will see. Case 4. Minimum drift. Now, let's say if velocity of the man in still water is less than u, means this guy can't swim faster than the river. That means he can never reach the opposite point. That is, he can't go along AB. Why he can't go along AB? Because if you see the river ka speed is more than his speed, even if he puts his full effort to fight the river, he will get drifted away. So the problem is, so okay, you can't reach the opposite point. So what is the closest you can get? It's like a compromise. You can't reach the opposite point. Fair enough. Like what is the closest you can get to point B? So if you see here, you are starting from here. Again, same story. Let the man go with V and an angle theta. So this is what I was saying. I don't know what the man is going to do. So we always start with an assumption he's going with B, and from there we try to prove everything. You don't make an assumption like he will go like this. You don't know. You have to prove it before saying he will go like this. So let the man go like this. So same story. If you look at the components, V cos theta, V sin theta. The river is pushing him with U. So resultant would be in the vertical direction V cos theta, and the river is pushing him horizontally with U minus V sin theta. So if you look at this person here, this is what he will feel. So he will feel vertically I'm going with V cos theta, and horizontally I'm going with U minus V sin theta. So the resultant is like this. So this person starts from here, you'll reach here. This is B. So how is he looking exactly? He is looking somewhat like this. He is looking somewhere else, but he's going somewhere else. Are you getting it? He's looking at an angle theta, but he's drifting along line AC. So this distance BC is your drift. So the question is, you can't reach B, but what is the closest you can go to B? So the time taken to cross the river is d by V cos theta. The drift BC is the horizontal velocity u minus V sin theta into time. So this turns out to be u minus V sin theta d by V cos theta. Now, if you see here, for different angles, you have different drifts. Depending on different angles, you get different drifts. Now, among all those drifts, there is one drift with the minimum value. Getting it? So what should we do? Maxima, minima. Now we need to differentiate this function with theta, and we have to find how should he swim for minimum drift. Have a look at this. Let's see that in the next page. So we found the drift if the man swims at an angle theta. So that means for different values of theta, we have different drifts. Among all of them, there is one which is the minimum. We need to find that guy. Please have a look at this thing. Now, this is not, he's not able to reach V because U is always greater than V. This term can never be 0. In case 2, right, the term was becoming 0, so he could reach B. Now it's not possible because we said the speed is less than the river. Even his best effort won't be sufficient. Any doubts on this page? Clear? Now, so we got the drift here. BC is u minus v sine theta d by v cos theta. So we get BC will be d into u by v sec theta minus tan theta. Since you want to do maximum minima, dBc by d theta would be d u by v. Sec theta का differential is sec theta tan theta. Tan का differential is sec square theta. This should be equal to 0. So this would be u by v tan theta is equal to sec theta. This would be sine theta v by u. Luckily, the answer looks like case 2, but be careful. Case 2 mein it was u by v. Case 4 mein it is v by u. It is reversed. Easy way to remember, sine theta is always less than 1. Since here u is greater than v, u is in the denominator. Case 2 mein v is greater than u, so v is in the denominator. Meaning, if this person goes with this angle, he will go to the minimum drift. And what is BC minimum then? So you have to put this value back in that. So minimum drift would be u minus v sine theta is v by u. D by v cos theta is 1 minus v square by u square. This would be u square minus v square by u d by v root over u square minus v square by u. This would be d by v into root over u square minus v square. This is your minimum drift. So you should swim with sine theta v by u, and you will have, this is the minimum distance you travel. This is your case 4. So if you can't swim faster than the river, this is the closest you can get to B. Have a look at this. So this is completely using calculus. There is a better way to prove this, but now see, it is always like that. If you're getting something faster, means you have to think more. Let's see that method also. You see whichever you're comfortable, you use that. This is always, even though it is a little lengthy, it is pretty straightforward. You know what is happening. Let me show you the same thing with using vectors without any calculus. But have a look at this first. Ask me anyone confused with the steps. Again, the story was always the same. Let the man go at angle theta. Two components, v cos theta, v sin theta. River is pushing with u horizontally. So vertical velocity v cos theta, horizontal velocity u minus v sin theta. Time taken only depends always on v cos theta. So I got time from d by v cos theta. The drift always depends on horizontal velocity into time. I got the drift in terms of theta. Now I need to find maximum minimum to differentiate. I got theta, kept it there, I got BC minimum. I mean, if you see in terms of steps, it is straightforward. Yeah, it takes time to solve though. Please have a look at the steps. Ask me if anyone is not clear, confused, not convinced, anything not clear, please ask. Next one. Now, how do we prove this in another way? Can I go ahead? Any doubts on this? Ansh, Janil, clear? Niharika, Raksha, got this? Ahana, Adi, Arya, clear? Arnav, Ojas, Vignajit, going ahead. Now look at the alternate thing. Basically, we are using vectors here. the triangle of vectors. We know this is A bar, this is B bar, this is the resultant vector R bar from the remaining tail to the remaining head. So if this is the velocity of the man in water, if and wait, if this is the velocity of the river with respect to ground, and if this is the velocity of the man in the water, that means the resultant of these two vectors would go like this. So this is how the man would actually swim. This is the velocity of the man when you see from the ground frame. So velocity of the man in the ground frame is velocity of the man with respect to water. This is what we have been doing with the pictures I was showing you till now. Vectorially, this is how it would look. Man swimming with water and water going with the ground. You always add them and then you get the resultant. Now here the catch is, now when you say the man can swim with speed v, what you're telling is, if you make a circle of radius v, these are all the possible directions the man can swim. And all these vectors will lie on a circle. These are all possible directions. Man can swim. And all these vectors, they lie on a circle of radius v. Meaning he can go left, he can go 1 degree, he can go 2 degree, 3 degree, 20 degree, 30, 90, 100, 120, 140, 150, 180. And if you take all these vectors, they all will lie on a circle. They lie on a circle of radius v. Agreed? These are all possible directions. Now, so these are all the possible directions here. Let the man start from here. This is your velocity of the river with respect to the ground. Now listen carefully here. Suppose if the man decides, okay, I will take this vector, meaning you decided to choose this vector. You can choose any vector, right? So if he decides to choose this vector, let's call it point 1. Then how should the man go? From here, man should go in this direction, right? Isn't that the meaning of it? The resultant is that if you choose that vector and the green vector, the black vector is the velocity of the man with respect to the water. Means how will he go? He will go like this straight line and he will eventually reach somewhere here. That is the meaning of this. If he chooses this point 1, he will reach this point 1. Is this making sense? Suppose if you choose this point 2, then the man will reach here. Suppose if the man chooses this point here 3, that means the man decided to choose this vector. Then the resultant would pass like this. So if the man decides to choose this point 4, this will reach here. So did you notice something here? Which point has the closest distance? When the resultant vector becomes a tangent to the circle. If you look at here, when this point 2 becomes a tangent, you get the minimum distance. Are you getting this? So basically, this is what you have been doing. You are choosing a random vector like this. And you are choosing this is the velocity of the river. And then you are saying this is the resultant vector. Means you would go like this. So if you choose different points on the circle, you will reach different points. So here we can clearly see, we observe minimum drift when velocity of the man with respect to the ground becomes a tangent to the circle. Because if you take any other point, meaning just look at this thing. If I take this point, you're going here. If I take this point, you're going here. If I take this point, you're going here. If I take this point, you are going here. And after this, if you take this point, again you're coming back, isn't it? The tangent is the best. After that, again you're coming back. Becomes a tangent to the circle. Now, that's why I said this is a little more complex. So we have a circle. So from this point to this point, this velocity is u. From this point to this point is velocity v. And now you're saying this will become a tangent. So this is 90. This angle is theta. So this angle is theta. And we can clearly see from here, sine theta is opposite side v by adjacent u. So if the man swims with this angle, sine theta v by u, he gets minimum drift. Is this logic making sense? This is pure vectors. There's no calculus, nothing. So we are saying the man can go with different vectors on the circle. Different points will give you different paths. Right? So basically this is, if the man chooses this vector 4, this would have been the path. He would reach 0.4 on shore. Now you see which one you're comfortable. If you ask me, this is any day safer. But involves calculation. It is little lengthy. This thing, it took time me to explain, but if you actually know how to do it, it will be like 2 steps in the exam, isn't it? Man can go anywhere on a circle, radius is v. The river is going with you. The resultant of these two vectors must be a tangent. So if this is theta, sine theta v by u. Done. You got the answer. It looks fast if you know what you're doing. But if you are confused what the hell is happening, the whole thing will go for a toss. This is an alternate solution. Again, remember this thing every time, right? We teachers will keep you teaching you 2 to 3 methods. Doesn't mean you should know everything. You be comfortable and confident with one method sufficient. You are not doing any research here. You see which one you are happy, comfortable. Even if it takes 1 minute more, right? Choose a method which you're confident, because exam you should be able to replicate it. What is the point of going to the exam and getting confused? But is the logic clear, everyone? There, you can prove this without calculus. I just wanted to show you that, nothing but, because triangle law, we never used it much. The poor thing also wanted to feel like it is important. So we made triangle law feel important. Clear? This is your case 4. Now let's see some questions. Every time you won't keep getting these 4 cases. Turn in the page. Any doubts? Anyone not convinced with this? Confused? Please ask. Daksh, Arnav, Jainil, clear. Purvaja, Pratik, got this? Clear, na, Purvaja? Yeah. Yeah, let's get this. Yes, yeah, river is flowing with speed 1. Man wants to go to point C. He wants to go to C, yeah? He doesn't want to go to B. So this is not a minimum distance. This is not minimum time. This is not case 4. This is none of the cases. Let's solve. If you already know the answer, it is good, but I hope you already know how to do it also. Knowing the answer won't help you. And this is a more than one choice question, so there are two answers. Try. You got a minute or two. ठीक है ना, it is there in the week ka test, but did you do it in the exam also? Then it is fine. Let's see. Let's see. Hmm. Straightforward. Now, if you look at the diagram now, diagram is little maybe confusing. The C is somewhere here, okay? You can actually guess this. Can someone guess this? Acha, logic ta dekho. It is like he's saying A, B, and B, C are 400. So this is A, this is B. If this is C, this is 400. So this angle is 45. Now you tell me, logically, suppose if I swim at 45 and the river is pushing me like this, you think I'll go along C? Won't I go like this? Make sense? So the question is saying I want to go along 45. So if you want to go along 45, means you should swim little higher, then the river will push you horizontally, then the resultant will be along this thing. Isn't making sense? So one thing is clear, answer is definitely greater than 45. You could have guessed that much without doing anything. And if you had guessed 45, then the only answer is 53. If you got 53 using this thing, you can find the second answer. But let's see how to do this normally. That's what I keep saying. In the exam, what matters is only the answer. After the exam, the only thing that matters is concept. You should have two sides like that. So let's see. So let this person go at an angle theta. So this component would be V sine theta. This component is V cos theta. On top of it, the river is also pushing you with the speed U. Then the resultant is going like this, A to C. This is B. You can clearly see here, B to C is 400 meters. A to B is also 400 meters. That gives you an angle tan theta 45 degrees. So from here, we can see the geometry. Tan 45 is the vertical velocity V sine theta by horizontal velocity V cos theta plus C. This is equal to 1. V is 5. This is 5 cos theta and U is 1. We can clearly see sine theta minus cos theta is 1 by 5. If I try to solve this, it becomes quite complex actually. You can clearly see by putting substitution, theta 53 gets done properly. If you try, you have to use trigonometric equations and solve this. multiply and divide by, something like 1 by root 2 and then try to find, it becomes complex. But you can clearly see if you put 53 degrees, sine 53 is 4 by 5, cos 53 is 3 by 5, that is 1 by 5. And what about the time taken? You can clearly see time taken depends only on the vertical component, which is v along AB. So AB is 0.4 kilometers and velocity along AB is v sine theta. So this is 0.4 by 5 and sine 53 is 4 by 5. That is 0.1 hour. In 1 hour, you have 60 minutes. That is 0.1 into 60 minutes. That is 6 minutes. So the answer is B and I check. Now this mathematically we should do, but like I said, we're not a max class. Options are given, so just put and finish it off. Don't waste your time trying to actually simplify that because you won't get any proper numbers there. It's pretty messed up. Have a look at this. Clear? Let's see one more. So, if you have to draw how is he going, this is the path. The man is here, B is here, C is here. This is some D here. The man is going like this. But this person, right, when he started swimming, this is what is happening. He's looking at D, but he's going along this way. You're getting? You're looking at D, but you're moving along C. This is how what is happening in all these problems. You're looking somewhere else and you're walking somewhere else. Got this? Let's see one more. Let's get this. Swimmer crosses a flowing stream of width W, to and fro in time D1. Time taken to cover the same distance up and down the stream is T2. T3 is the swimmer who take swim in still water. Find the relation between them. Right, Arnav. If you understood the thing, this is what is happening. He goes to and fro in time T1. So So A to B is going like this and is coming like this. The river is flowing with you. Basically, this is case 2. And he's saying the time t1 will be w by root over v square minus u square into 2 times. That is case 2. The answer is A, regards. The second one, he is swimming in the river down the stream. So down the stream he is going with v plus u, while coming up he is going with v minus u. So this is t2, which is w by v plus u and w by v minus u. Simplify this, you'll get 2w by v square minus u square. The third case, the river is at rest, u is 0. So you're simply swimming with speed v and 2w distance. So time t3 will be 2w by v. If you can simply do that, t1 square, if you do this, you will get t2 into t3. We have to go from options. There's no way out. Yeah, but this much you can feel actually, if you multiply t1 and t2, you get nothing. So this guy is gone. You have to check the other two. T2 square also is gone. You're getting v square minus u square ka whole square. That doesn't make sense. So it is clear you have to multiply t1 square only. That you will see when you try to simplify. But yeah, I hope you got the cases. So this is case 1. So this is a combination of case 1 and case 2. The third one is the same thing, meaning we're just going around. All clear with this? Next one. Any doubts on this? Next one. Next one's a good one. Now, every time they won't keep saying river and boat and all, we can change the question also into an aeroplane. So an aeroplane pilot wants to fly from city A to B. So here the aeroplane is the man. The wind velocity is like the river. That's it. So it's exactly the same question. You simply replaced man with aeroplane and the wind with river with wind. And this is actually true. Huh? Ever heard this word called slipstreams? Normally on the land, right, we have rivers flowing. In atmosphere, we have something called slipstreams. These are, air currents which are flowing. So if you take your plane or object along the slipstream, right, you gain the speed of the slipstream just like a river. So there is an European company, right, which actually tracks all these slipstreams and they sell the data to, aeroplane companies, meaning these airlines. Meaning just imagine you have a slipstream like this. So what these planes will do, they will enter the slipstream, they will go with the slipstream and they'll take a turn like this. Because as long as you're traveling on the slipstream, you get that additional speed. Now, let's say if the slipstream is going with 80 kilometers per hour, you get the extra speed of 80 kilometers per hour. And if you can get that extra speed 80 kilometers per hour, even for 400 kilometers, that saves you a lot of fuel. And in the plane ticket, almost 40 to 50% of cost actually goes in fuel only. Similarly, there is also something called underwater currents, just like there are rivers inside the ocean. Saw this Finding Nemo? That is how it gets lost actually. There's an underwater current, the fish goes and it gets drifted off. So on the land, we call it rivers, right? And then in the rivers, in the atmosphere, we call it slipstreams, and under the ocean, it is an underwater currents. Abhinav, God, there are options there. Please check. First, try to draw the diagram. Like I keep saying, the important thing is if you can draw the diagram, you understood what is happening. Take a minute, try to figure out the diagram. Then I'll show you the diagram. Then I'll give another 2 minutes. See the diagram. This pilot here wants to go from A to this city B, say due north, 1,000 kilometers. But he ignored the wind effect and reached somewhere else, C, which is a distance of 300 kilometers northeast, meaning this angle is 45 degrees. So this guy went away like this. Meaning, but if you see in this entire process, if you look at the plane was always looking like this. I know that doesn't look like plane, but yeah. The plane is always looking straight. You're getting it? The plane is looking straight, but it is actually drifting towards sea. Got this? What happened? So the wind is pushing the plane instead of going towards where you went to sea. Now here I want to teach you something. Sometimes in the questions, right? Here it is easy, 45 degrees north of east. Sometimes you'll hear the words like this, 30 degrees north of west. What do you mean by this? Look at the word, 30 degrees north of west, meaning from west, go 30 degrees towards north. Meaning go 30 degrees towards north. You're getting the interpretation of that? 30 degrees north of west. So west said go 30 degrees towards north, meaning he's talking about that angle. Can you tell me what is this 60 degrees east of south? East of south, meaning south ka east side, go 60 degrees. Are you getting the interpretation of this? If I say one more, let's say 15 degrees north of east, then east ka you have to go towards north 15 degrees. There. So that is how sometimes in the exam you will get these kind of words. Luckily here, na 45 degree north of east or east of north is the same thing. There's no problem. Yeah, answer is A, but let's see how to do this. Try. I'll give you another minute or two. So this is important. North of west, east of south, west of north. The meanings of these things are important. Try. Let's see how to solve this. Again, the story is the same. Doesn't matter. We don't know how the wind is blowing. Let the wind gust speed be Vx I cap V by J cap. Start from there. When you don't know something, when you don't know how it is blowing, always take in vector components I cap and J cap, and start from there. Niharika, you logged in from 2 accounts. Try, everyone. Just give it a try. I'll be back in a minute. Let's see. See, since we don't know how the wind is blowing, let velocity of the wind be Vx I cap and Vy j cap. So here we have a plane which is flying straight with 500 kilometers per hour. On top of it, there is a wind blowing Vx and there's a wind blowing Vy. So when you add these two, so this plane is actually going straight with Vy plus 500 and it is going with Vx horizontally. Now, if you look at the trajectories here, so this is A, this was B, which was 1000 kilometers. This was C, and this was 300. So this distance would be 300 by root 2, that is 150 root 2. And this would be 150 root 2. And this plane ka speed is Vy plus 500 and the horizontal is Vx. So in the Y direction, the distance traveled is 1000 kilometers plus 150 root 2 vertically, and your speed is Vy plus 500, and the time taken is 2 hours. It is given. It is mentioned it takes 2 hours to reach the point C. Simplify this, you end up with Vy is equal to 150 by root 2. Same thing, if you take x direction, the distance traveled is 150 root 2. So basically the main thing is that you always keep your x and y separate and study it. The speed would be Vx into same time 2 hours. So Vx is also 150 by root 2. Therefore, the wind is going 150 by root 2. 150 by root 2. So when this wind is actually blowing 150 kilometers per hour northeast, 45 degrees. First option is the answer. Is this clear, everyone? Just like river, isn't it? There's no difference. But the only thing here is we don't know how the wind is blowing. So we start with an assumption, let it be Vx and Vy. Because any vector can be in a 2D plane, you can represent with I component and j component. Have a look at this.
So,
Hana.
can we know that the plane got displaced by 300 kilometer in 2 hours. So
Right.
in 1 hour, it got displaced by 150 kilometers, 45 in the 45-degree direction. So like we can
Right.
split it into
You can do that. That is much faster. I know. That is true.
150.
Right. What Anna is trying to say, right? In 2 hours, if the wind was not there, you would have traveled 1000 kilometers. And now from here, you got drifted this way 300 kilometers in 2 hours. So literally, all this drift BC happened because of the wind only, right? So how much is that? That is simply 300 by 2, 150 kilometers per hour northeast. हो गया ना एक step में answer. Is that making sense? Let's do one at a time. Na? There is a wind and there's a plane. Forget about the wind. So if the plane travels for 2 hours, where will it reach? It will reach B. 500 into 2. Then if the wind is blowing, you're reaching C. So you traveled 300 kilometers because of the wind at 45 degrees. In how much time? 2 hours. What is the speed? 150 kilometers per hour northeast. Clear? But I wanted to show you a general process because in this case, luckily the thing is coming straight. What if the plane is flying like this and the plane is reaching like this? So the angles are messed up. It will be more difficult. Anyways, that is not wrong. That is a much faster way.
Sir, it doesn't travel only for 300 kilometers in 2 hours, right? It travels.
It's traveling 300, no?
No, sir, it travels more than 300, right? In two
No, no.
hours.
Only if the plane itself can travel 1,000 on its own, no?
Yes, sir.
The extra 300 is because of the wind, right?
Okay.
That way. All got this? Next one. Next one. So there, all these questions, right, Firbi are like little, mains level questions. Let's see how they'll frame a question in advance. Now, if you ever seen actually a river flowing, rivers don't flow with constant speed. So we have a river here. Let's say this coordinate y is equal to 0. The center of the river y is d by 2, and the other side of the river is y is equal to d. So basically, the y coordinate. The total width of the river is d. So for a river, right, the velocity of the water at the banks is 0. Now, anytime if you have gone near a river, you must have observed the water at the edges, right, actually is flowing almost with 0 speed. But as you keep going inside, the speed increases and linearly increases and increases linearly to speed u till the center. Meaning, if you take a river, you will notice the speed on the edge is 0, then it increases a bit, then it increases a bit, then it increases more, and then it increases more. Then again it decreases, and again it decreases, again it decreases, and becomes 0. So this is how the speed would look like. At the center, the speed is maximum. Generally, this is true. If you see a river, right, the center it flows with the maximum speed. So the river speed is not constant. It is changing as you go more and more. So this coordinate y is 0, this coordinate is y is d by 2, and this coordinate is y is equal to d. I hope everyone has got the river part, what is happening. Now we have a person here who can swim in the still water with V. And this guy decides to swim straight. And he doesn't care about the river. He is swimming straight. But then you know what will happen? The river will drag him to the right side. Man swims straight with V. That is always looking ahead. Huh? He's looking ahead. He need not go ahead. He will go somewhere else to the right, but is looking always to the front. The first thing, find velocity of the river as function of y coordinate. This is important. You will keep hearing this word. Huh? Function is changing linearly. You will see this multiple times. We will recently also was teaching your seniors. We are talking about we were doing in thermodynamics. We saw it in waves. We saw it in multiple places. Find velocity of the river as function of y. Find the time taken to cross the river by the man. find the equation of trajectory of the man, meaning what is the path he goes, उसका equation चाहिए. Find the equation of trajectory, the drift, and path of the man. Meaning if you have to draw the path in which he goes, how will the path look like? Let's get this. There, this is how they'll determine advanced paragraph question. Nere. Let's see. The first one is more of a maths thing. Now you need to understand what do you mean by linear function. Whenever you say linear function, you must have studied this in school, equation of a straight line. So when you say a linear equation, you're talking about y is equal to mx plus c. Keep this in mind. When something says they're changing linearly, this is how it should look like. So if the velocity varies linearly, with y, meaning your velocity should look like v is equal to a into y plus b. A and b are some constants. So first, now understand one thing, the river is flowing little weird from 0 to d by 2. So we can't do directly from 0 to d. You have to do it in two parts. So first, let's do for 0 to d by 2. Like I said, it's more of a max thing. So at y is equal to 0, velocity of the river is 0. So this should be a into y coordinate is 0 plus b. So b ka value is 0. When the y coordinate is d by 2, the river ka speed is u. This is a, d by 2, and b is anyway 0. So A ka value is 2u by d. That means the velocity of the river is 2u by d into y. So from 0 to d by 2, the river is flowing with this velocity as a function. So from 0 to the center, this is the velocity function. I'll write down the whole thing again. Now, if you go between d by 2 to d, meaning the upper half of the river, let the velocity v be p into y plus q. I could have used ay plus b, but unnecessarily you might get confused with this. So I'm taking some other variables. See, the important thing is it should look like this. You can have any variables you want. P and q are constants. Again, same story. When y is d by 2, the velocity of the river is u. So this is p into d by 2 plus q. At y is equal to d, the upper part of the river velocity is 0. This is p into d plus q. You have two equations, two unknowns, subtract them. We have u is equal to minus pd by 2. So we have p is equal to minus 2u by d. And if you substitute here, q ka value is minus pd is 2u. That means the velocity of the river is minus 2u by d into y plus 2y. Now, if I combine all this, the velocity of the river is given by 2u by d into the y coordinate. This is a function for the river from the bottom to the center. Once you cross the center, the function is linear, but it is little different. 2u by d into y plus 2u. This is the velocity, or this is the function for y between d to d by 2. This is how you do this thing. So it's not a one single function for the entire river. There are two functions in the river. If you try to plot this in a graph, velocity of the river versus the y coordinate, the velocity would increase linearly and then decrease linearly. This is how the graph would have looked, where the velocity peaks at point E. Like I said, this is more of a max question than physics. Since you said increasing linearly and decreasing linearly, you have to do this. You have to split them into two functions because there are two different straight lines. And the linear equation meaning this. So I assumed v is a plus by b, and I assumed v is py plus q. And I know the values. At y0, v is 0, y d by 2, v is u, y d by 2, v is u, y d, v is u. Substitute four equations, four unknowns, solve. You'll get all the constants. Please have a look at this. This is pure max. There is no physics in this. This is how you always solve linear functions. When you hear these words, if you see now, there is a question we did this recently for your seniors. Temperature varies linearly from x is equal to 0 to 100, from 100 to 300. Same story, we did the same thing. Let the temperature be x plus b, at x is equal to 0 this, at x is equal to 0 this, we got temperature. This also. So here the radius is varying linearly. So we started with the same thing. R is equal to px plus q, x is equal to this, x is equal to this. It's not a one time. You'll keep hearing this word linearly, linearly. And this is how they expect you to handle. Let the function be something like ax plus b, substitute the values and find a and b. Have a look at this. This is the first part. Question is still not over. Any doubts on this page, please ask me. The second question was what? Find the time taken to cross the river. The third question was equation of trajectory, drift of the man, and the path of the man. In this entire thing, actually, the second is the most easiest question. Time taken to cross is the easiest one. But any doubts on this page, please ask. Clear? What about the time, anyone? Now see, tell me one thing. When the man is swimming, which velocity is responsible to cross the river? The vertical or the horizontal? The man is swinging up and down. What matters is only his velocity, isn't it? This is the velocity of the man. I agree, river ka velocity is changing, but that is always horizontal. So time taken to cross the river will be d by velocity along d, the vertical, which is d by v man, which is v. This is independent of river ka velocity. Because river will never help you. River will always take you left and right. It will never take you up and down. So river ka speed is useless. This is independent of river speed. Even though it is changing, it's unaffected. It doesn't matter. Man won't go in a line, but it doesn't matter. Clear? And if you look at the C part, at this point we have y is equal to 0. If you see, this is actually a curve. Man is going in some random curve. At any point, if you see the velocity, this would be v river. This would be the velocity of the man. So at a particular point, let the coordinates be x comma y. So the y coordinate depends on velocity of the man, because river will not take you up and down into time. So this is vt. That's your y coordinate, everyone. Velocity of the river is given by, we just now calculated this, 2u by d into y coordinate. This is for y between d by 2 to 0. It's not constant. So this is 2u by d, and y coordinate is v into t. Velocity of the river is dx by dt. We have to integrate because velocity is not constant. The more you travel, more the speed. So when you integrate this, you end up with dx is 2uv by d t dt integral 0 to x and 0 to t. That turns out to be x is equal to 2uy by dt square by 2. You get uv by dt square. That is your x coordinate. There, you got your x coordinate and then you got your y coordinate. So this y coordinate is a straightforward velocity of man. X coordinate, you have to put some effort because it's not a constant. X coordinate depends on y coordinate, and y is vt. So we have to integrate this. Now from this two, we can eliminate. X is equal to uv by d, and t is nothing but y by v whole square. This turns out to be u by v d into y square. This is your equation of trajectory. We discussed this. Equation of trajectory is simply relation between x and y coordinate. And if you see this shape, it's a parabola. Man is not going in a line. Have a look at this. Let me show you how the trajectory will be in the next page. So without the first part, you won't get the second part, third part. You need to, that linear thing is important. Please have a look at this page. You should definitely try this whole problem on your own. First time you might not get an idea, but now you know. So if you see something like this again, don't mess it up. That is how you should always be thinking. It's okay not to get it in the class, but after you saw it for the first time and you learned it, something similar comes, you should not be leaving it.
So for the second part where d by 2 is less than y and y is greater than d, the equation of trajectory will be different.
Will be different, na?
Yes.
Change ho jayega trajectory. This is only for y between d by 2 to 0. But from this we can manipulate it. Matlab we can say it will look like this, but thoda invert ho jayega. So we're not going to prove that, but we'll say it will be symmetrical. So this is how it would look. You start from here, y is equal to 0. It would look like this. Now, for people who are confused, y is equal to x square. This looks like this. It's an upward parabola. X is equal to y square. This is a horizontal parabola. That's how this thing would look. Like this. And if you see by symmetry, the same thing will happen here in the reverse. And the best part is this. They will start perpendicularly, obviously, because if you look at the velocities here, this is the velocity of the man, which is constant. Here, velocity of the river is 0. Here, this is the velocity of the man. Here, velocity of the river is a little more. You're getting it? The man is actually, so this is the velocity of the river, man. At the center, velocity of the man is the highest. Sorry, river is highest. Then again, when you go here, again, river ka speed is decreasing. Again, when you reach here, only man ka velocity is there. So when you enter the banks and leave the bank, your velocity should be perpendicular. And in this entire process, you know, what is the man doing? The man is looking straight up. The man is looking like this only. But the poor guy is going in some weird angle. You're swimming straight, but you're going in complete parabolic path. And what about the drift here? So what we got is only this equation. So we got the equation x is equal to u by vd into y square. For y is equal to d by 2, we get x coordinate is u by vd d square by 4, which is ud by 4v. That means for the first half of the path, you will travel a distance of ud by 4v. By symmetry, we can also say this also will be ud by 4v. Whatever happens, the same thing happens there in the reverse direction. So the total drift will be ud by 2v. The man has gone horizontally ud by 2v. This is the path. This is how it looks. Two parabolas. Meaning, if you had completed this now, this would be like this. This is one parabola, and this is another parabola. This is like this half parabola here. Part of that and part of this. Do have a look at this. This is how an advanced paragraph question would look like. This is your total drift. So do definitely try to do this. So the main thing is getting the velocity of the river as function of y coordinate. And then, you know, y is vt, substituting and integrating. Once you got x and y, it's mostly done. Clear with this, everyone? Next one. Turn in the page. So do definitely try these things what we did. Like I said, relative motion is not, at least the riverboat and all, right? They're not tough, but yeah, this is tough one. So this you should definitely try this on your own. The next thing is a flag problems. So there's another type of problems that we have. So a straightforward concept. Consider a flag on a vehicle. So now we want to find if the vehicle is moving and the wind is blowing, how will the flag move or which direction will the flag point? So primarily there are only two cases. Case one, let's say wind is blowing and vehicle is at rest. Then what we'll notice, this is simple, kind of, meaning you must have noticed it. If the wind is blowing, the flag also will point in the direction of wind. Sometimes I can ask you like this also. They will say a chimney is there and smoke is coming out of it. Idea is the same. The smoke will point out in the direction of the wind. So they can ask problems like this also. On a boat, there is a a steamer where there is a this thing. Smoke is coming out of this steamer, and the boat is going with so and so speed, and the wind is blowing this way. What will happen to the smoke? Case two. Let's say there is no wind, but a vehicle is moving. This is also straightforward. You must have noticed it when you're going on your scooty or car or something. If you try to put a cloth or something, it will always point opposite to the vehicle. The same thing you can say about a boat also. If the boat is going this way, the smoke will go backward. Clear? That's it. These are the two cases. These are pretty obvious cases. Matlab, I'm sure you must have observed this. If the wind is blowing, flag will go with the wind. If the vehicle is moving, it will be opposite to the vehicle. Any doubts on this? Let's see a question on this. Turn in the page. You have a vehicle moves east with 10 meters per second. And the wind blows northeast 10 root 2 meters per second. In which direction does the flag point? Hmm. Then look at the idea there. North, east, west, south. So vehicle is moving east, so the flag will go backward 10 meter per second. This is due to vehicle. So this is the case two basically. Whichever direction the vehicle goes, uska opposite. The wind is blowing northeast, so it will go with the wind 10 root 2. Northeast meaning this is 45. So resolve this into components. This will be 10, 10, and 10. So they will cancel out. So the resultant is 10 upward. So done. Na? Answer is north. Easy. Just basic vectors basically. Let's see one more. Next thing. Let's say we have a big river. The river is flowing 20 meter per second. Okay. We have a boat here. Boat is going north 10 meter per second. Again, boat moves north with respect to water. Meaning the boat is trying to go straight. And on top of this, now there is a wind also blowing here. The wind is blowing 10 root 2 meters per second southwest. Now, in which direction is the flag point? Let's get this. Let's see. First thing, the river is going to the right. So this is 20 meter per second. The flag will go opposite due to river. Because see, whichever speed the river goes, the boat also will go in that way. The flag will go opposite to that. So simply remember like this. The only time it will go with the thing is the wind only. For everyone else, it is opposite. The wind is dragging you this way, 10 root 2. This is due to the wind. So the flag only goes with the wind. It is opposite to everyone else. Boat is going north, so this will go south. This is due to boat. Then it just becomes a vector problem. So this is 20. 10 root 2 ka component is 10. This is also 10 and this is also 10. So resultant would be 30. This would be 20. So this guy is going something like this. You can say this angle is alpha. So tan alpha is 30 by 20 or 3 by 2. So you can say boat moves alpha e west of south. South ka west side we have to go alpha. It's not a standard angle. So Yeah. Clear with this? With that, we are done with the relative motion. So if you see in relative motion was quite a big one. We had different things. First thing, especially if you remember, the cat and dog problems. Then we had particles chasing each other. Then we had, minimum distance between the projectiles. Those were important. Those were important. And then Rainman was fine. And Riverboat, there are variations we saw today. And then we have this flag problem. So if you say relative motion, there are a bunch of different varieties there. So after this, we are left with graphs. So on Thursday, when we catch up, right, we'll start off with the graphs. That should take around 1.5, 2 classes. So we should wrap it up by next week. Kinematics will be done.